Hi, in this video I'm going to be going over how to do question number 14 on homework 3. The question says, a proton with the initial speed of 800,000 meters per second is brought to rest by an electric field. Part A asks, did the proton move into a region of higher or lower potential? To start to answer this question, we need to think about three different equations. The first is that kinetic energy plus potential energy is equal to 0. Then we need to think about the equations for kinetic and potential energy, as well as electric potential. So we know that kinetic energy is equal to 1/2 mass times velocity squared, and potential energy is equal to the charge times the change in electric potential. And I like to put this cross through the V that stands for electric potential just to make it look different from the velocity V. Rearranging this, we know that this electric potential is equal to the change in potential energy over the charge. Now I think we're ready to answer this question. So since we know that the velocity of this proton is decreasing, that tells us something about the kinetic energy. So the velocity is decreasing, and since kinetic energy and velocity are directly related, we know that that means the kinetic energy is also decreasing. From that, we go back up to this question, and we know that if kinetic energy decreases, potential energy must increase in order to maintain that 0. Finally, plugging this in to this equation for the electric potential, we know that if the potential energy is increasing, since it's directly related to electric potential, the electric potential is also increasing. And that gives us our answer. I wrote part B on a separate piece of paper because we're going to need a little more room. Part B asks, what was the potential difference that stopped the proton? I've also written out this list of knowns and equations from the problem, just so that it's a little simpler and we don't have to waste time doing that. So from the problem, we know that the proton started out with a velocity of 800,000 meters per second, and that it ends at rest, which is 0 meters per second. The charge and mass of a proton are constants, and we know those too. This should say kilograms. In solving this, let's again start with this equation that says that the change in kinetic energy plus the change in potential energy is equal to 0. Now it's useful here to remember that a change is always final minus initial. Substituting this in for the kinetic energy and this for the potential energy, as well as including these final minus initials, we get the equation that looks like 1/2 mass times velocity final squared minus 1/2 mass times velocity initial squared plus the charge times potential final minus charge times potential initial. And that is all equal to 0. Rearranging this, we find that 1/2 mass velocity final squared plus charge times potential final is equal to 1/2 mass times velocity initial squared plus charge times potential initial. Let's remember that what we want to solve for is the change in potential, which means that that will be this big V F minus VI, which is final and initial. So rearranging this, solving algebraically to get VF minus VI, we get VF minus VI is equal to 1/2 mass volume initial squared minus 1/2 mass volume, velocity final squared divided by charge. We can then cancel out this term because the final velocity is a 0, and so multiplying 0 by all of this just gives you 0. So we end with that the change in potential is equal to 1/2 mass times velocity initial squared over the charge. Now we plug in these given values. And then solving numerically, we find that this change in potential is 3,340 volts. I'm now going to show how we derived this unit of volts. One volt is equal to 1 joule over 1 coulomb. You'll remember that what we had as our final equation was a mass in kilograms times a velocity in meters per second, and that was squared, over a coulomb. 1 joule is equal to 1 kilogram meters squared per second squared. Multiplying this out, we find that on top we have kilograms meters squared per second squared, and divide that by coulomb, which is the same as kilogram meters squared over second squared times coulombs, which is equal to 1 joule over 1 coulomb, which is equal to 1 volt. And that is question 14 on homework 3. I hope that's helpful.